talk about an idea out of section 4.3. And it's going to be an idea that we're going to be using throughout the whole year. And that is how to measure angles in standard position. So we need kind of a uniform way to measure angles in the coordinate plane, so that if I'm talking about an angle of 200 degrees, that someone would know where the initial and terminal sides of the angle are. Somebody anywhere in the world, that we would all kind of have the same convention, so to speak. So this convention is used in pretty much all textbooks all over the world. People use this when they're writing papers, anything using trigonometric functions. This is very, very standard the world over. So it just gives us all kind of the same lens for which to view angles in the coordinate plane. So I'll draw my coordinate plane here for reference. Okay, so now in order to construct an angle, I kind of need two sides, and the angle is going to be kind of wedged in between there. So for standard position, the initial side is always the x-axis. Always, always, always. So we're always going to start our angles with one of the sides using the x-axis here, the side on with positive x values. So that's always the initial side. The terminal side. The terminal side is wherever you stop. So you're going to traverse your theta and then you're going to stop. So the terminal side is where you stop. And if theta is positive, so positive theta or positive angles means we're going to move counterclockwise. So that means we're just going to have to look at some examples here. So let's say theta was 60 degrees. So that means you're going to start on the x-axis, the positive x-axis. Now we're going to use that to then create a 60-degree angle. So that means that my terminal side is going to be right about here. There's my terminal side. So that means between the initial and the terminal side, you're making an angle of 60 degrees. So that terminal side would be in quadrant 1. Because notice that the initial side of the x-axis, if your terminal side was the y-axis, that would make a theta of 90 degrees. So I'm a little bit less than that. So that means that my terminal side is going to end up in quadrant 1. So there I've constructed an angle of 60 degrees. So now, since this is universal notation, essentially now, whenever we're talking about an angle of 60 degrees and we're using the coordinate plane here, everyone would put that angle in quadrant 1. Okay, so let's look at just some more examples. So let's say theta was 150 degrees. Okay, so my first side is going to be on, my initial side's going to be on the x-axis there. Now that means I need to sweep out 150 degrees, which is less than 180 degrees. Okay, so that means my terminal side is going to fall in quadrant 2. So that means I'm starting here, I'm sweeping out all the way over to here, making that 150 degrees. Notice, starting from the initial side of the x-axis, going up to the y-axis, that's 90 degrees. And I'm not going to make it all the way back down to the x-axis pointing in the negative direction, because that would be 180 degrees. So I know if I'm going more than 90 degrees but less than 180 degrees, I'm going to wind up with my terminal side in quadrant 2. Okay, so let's look at an example that would end up in, say, quadrant 3. So let's say we have theta being 240. So that means that my initial side starts on the x-axis. So 240, I'm going to end up in quadrant 3 because I'm going around from the initial side all the way back around to the x-axis. That's 180. Now I need to go more. Now I'm not going to make it all the way back around to the y-axis because the different following right on the axes, they kind of happen at 90-degree intervals. So between the positive x-axis and positive y-axis, that's 90. Back down to the x-axis, that's 180. Now if I made it all the way around to the y-axis, that'd be 270. But I'm stopping at 240, so it means I'm going to stop short of making it back to the y-axis. And that's going to stop in quadrant 3. Now, notice that I could also measure my angles, and I could call theta negative, and that's if I have a negative theta value, and that just means that I'm going to measure my angle going clockwise. So if I had theta being negative 120 degrees, so I start on the initial side, my x-axis. Now I'm going to go negative 120 degrees, which means I'm going to measure out theta going clockwise. So that would stop over in quadrant 3. So I'm measuring just going clockwise instead of counterclockwise if theta is negative. Now notice something here. Notice that when theta is 240 and when theta is negative 120, the initial side and the terminal side are both in the exact same place. So if you think about it, if I'm just going to mark on the 240 one here, if I would have went clockwise 120 degrees, I would have wound up in the same place. Because if you look at this, the 240 plus the 120, 360, that would bring me back around to where I started. So we have a special name for those angles. We would say that 240 degrees, and negative 120 degrees are coterminal. And angles that are coterminal, the definition of coterminal, forgot my little dash there. I wanted to put the colon here. So, two angles are coterminal if they have the same initial, and you have to have both terminal side. So that means any two angles that have the same, and when you're talking about angles in the plane, they're all going to have the same initial side because just by definition the initial side is always the positive x-axis. So it's basically that's always satisfied. So if you have the same terminal side, if your angle ends in the same place, then you're coterminal. So 240 and negative 120 are coterminal. And really, if you take any angle and you add or subtract any multiple of 360, you're going to obtain another angle that's coterminal. So for example, if I drew a picture with theta being 500 degrees, means I'd start on my initial side. I would go around 360, but I have to go 500 degrees, so I would have to go around another 240, and look at that, I would wind up at the same place as if I just went around 240 degrees, because 240 plus 360 is 500. Now it should make sense that those two are coterminal because any terminal side, if you added 360 degrees to that angle, 360 degrees is just one full lap around the circle, you would end right back where you started. So you can take any angle and add any multiple of 360 or subtract any multiple of 360, and you're going to get an angle that's coterminal.